Hello, this video is for Stat 110, section 6.1 for pages 9 through 13, which is the second example in section 6.1. Okay, let's go ahead and get started then. So here is the section 6.1 notes. Starting on page 9 here, we have our ear infection example, which we actually looked at the ear infection example back in chapter 2. So we're going to revisit this example. The ear infection example was done with pairs of babies, and we wanted to look at whether or not breastfeeding or bottle feeding had an effect on ear infections. So was there a difference in the length of ear infections between breastfed and bottle-fed babies? So here is, again, we paired the babies up according to different socioeconomics variables, things like their age and whether or not they had access to health care and the types of medications, etc. So what we did back before was just looked at a comparison between breastfed and bottle-fed, but we just kept a tally of how often the breastfed babies won out, which was 16 times, versus how often a bottle-fed baby won out, which was 7 times. Now, when we did this analysis before, we needed to worry about the fact that ties were not allowed. So here, that's a tie, and I don't actually give a tally there for that one. Now, with our paired t-tests that we're working with in section 6.1, our approach is going to be to compute the differences, and we don't have to worry about the tie. The tie is actually a good thing. Well, I shouldn't say a good thing, but it suggests that there's actually no difference between breastfed and bottle-fed. Now, when I'm looking at these, many of these numbers are negative, which means that the breastfed days, okay, and this is duration of fluid in their inner ear. So duration of fluid in their inner ear here. The breastfed babies tend to have smaller days than the bottle-fed babies. A lot of these numbers are negative. The other thing that we're going to see is that I have 3 very extreme outliers here. 158, 165, and 169. And we're going to want to address those when we do our analysis in our spreadsheet. Okay, so let's go ahead and maybe go over to the spreadsheet here quickly. We're going to do our standard thing like we did with our first example. We're going to compute the differences. And I'm just going to let the spreadsheet do that. I'm going to copy that down for all of those. And again, you can kind of see some of my extreme values there. And what that's going to do is really mess up my average here. So when I go and let's go ahead and do some summaries on that difference column. Again, under the values box here, I want to do the analysis on the differences. I can get the average here. And you can see that the average is minus 26. If I compare that against the median, let's go ahead and do the median. The median is minus 3. Now, the reason I have such a large discrepancy between the average and the median is, again, because of those 3 outliers there. That one there, that one there, and that one there are really messing up my mean. So I would advocate not doing a standard t-test without worrying about those 3 observations. You can see there with the box plots that those 3 are sticking out a lot. You can see it on a histogram as well, that those 3 are way out there. We do have some here at negative 40, negative 60, kind of in that range. We do have a little bit here, but these 3 out here are very extreme. So what we're going to do in our analysis is remove those. Okay. Before I decide, again, another approach that I could take here is to do a z-score. That's one way, again, to do a formula-based approach to detect outliers. So all I do to compute a z-score is just to take the data value minus the average, divide by the standard deviation. So I would have to take every value minus 26, divide by 55 here. I suppose I could do that. So let's do a z-score calculation here. So I take the data value, which is this one here, minus the average, which was minus 26.04. So make sure and get that minus in there. and then divide by the standard deviation, which is 55.09. Let's autofill that in. And any of these that are less than -2, that one, and that one are going to be flagged as outliers. Any of them that are bigger than 2 would be outliers as well. But I don't think I have any outliers on the upper end. I just have outliers here in the lower end. Okay, so those are definitely, again, if I use the box plots, or if I look at the histogram, or if I use the formula-based approach with the z-scores, you can definitely see that these are outliers. So I'm going to compute those differences without those 3 observations. So all I need to do to get that is to go back here. Let's go ahead and get rid of that column. I don't need that one anymore. And I'm just going to get rid of those differences here. Okay, so all I got to do is just delete them out. I can go back over here to my pivot table, and I should be able to do a, oops, let's go ahead and change this back to the average. That average before was -26. Now it drops down to -6. And that's a more reasonable value. If you look at all of these values in our spreadsheet here, -6 looks like it's a more reasonable value for trending on what a typical difference is, not -26. So that's what I'm going to do here, is we're going to compute the differences. Again, take out those 3. I can get a standard deviation, goes from 55 clear down to 15. And the number that I have now is not the 24 that I started with, but 24 minus 3, because I'm going to delete out those 3 outliers. So that's kind of my summary statistics there. Now I'm going to go ahead and do my t-test again. I'm going to do a paired t-test. Okay. And I want to know whether or not a difference exists between these two. So do I have a research question? I do, way up here. Is there a difference in the average duration of, okay, so is there a difference? So this is going to be a 2-sided test again. We just want to know whether or not there's a difference. So I'm going to be testing 0 again, just like we did before. Again, the first example is going to be, if you're looking for another example for this, I posted another video of that first example that includes pages 1 through 8. Okay, so again, that's where this is coming from. I want to test the value of 0 again. Let me go ahead and put that all the way down. But then I need to remove those 3 again that were not included here. So I got to make sure and delete these out. So those have to be missing or absent for both the difference and the test value. To get the p-value here, I just go equal t-test again. The first column is going to be my difference column, and then my test values. The 2 again, because I'm doing two-tailed again. So both of the examples in section 6.1 are two-tailed. And then the 1, because I am doing a paired t-test. So that's always going to be a 1 there in section 6.1. When I hit enter here, I get 0.067. So that's going to be my p-value. That one now is not less than 0.05. It is close, but it's not less than 0.05. So let's go ahead and put the p-value in here. Hopefully I got a spot for that for you. I do. 0.067. Again, what we need to do is compare this against 0.05. So is 0.067 less than 0.05? No. So we don't have enough evidence for the research question. Oops, I can spell question. So that's going to be our decision there. Getting ahead of myself a little bit, but that's don't have enough evidence for the research question. Now it's close, all right, but technically speaking, we don't have enough evidence for the research question. So let's go ahead and write our final conclusion here again. We are 95% certain, oops. We are 95% certain that there is not enough statistical evidence to say, okay, and what are we testing here? Go back up here, finally, there it is, to say that a difference exists in the duration of fluid in the inner ear for breastfed and bottle-fed babies. Okay, so let's drop that right in there to say, paste that without, a difference exists in the average duration for ear infection between breastfed and bottle-fed babies. The p-value here is 0.067. So again, it has the 3 parts. Do not have enough evidence this time. Whatever the research question is, and then put that p-value in there. Let's go ahead and compute the margin of error, or the confidence interval. So here, again, my average is negative 6.63, or negative 6.33. And then I need to subtract 2 times the standard deviation divided by the square root of the count. So this is going to be 14.99 divided by the square root of 21. Whatever that number is, let's go ahead and figure that out. And then the upper end point is going to be, starting at 6.33, I'm going to add now, I'm going to go up 2 times that same quantity. This quantity here, again, is the margin of error quantity. So let's go ahead and grab my calculator and do those calculations quick. I'll do one of them here anyway. What do we have here? Square root of 21, I need that first, which is 4.58. Take 14.99 divided by 4.58. And I get about 3.27, it looks like. I need to multiply that by 2. And I get 6.54. Or let's say 6.55. So this part of the equation is 6.55. So I'm going to take negative 6.33 and minus 6.55. And I'm going to take negative 6.33 and I'm going to add 6.55. Okay, because I add in the second one here. So what do I get when I do that math? Let's go ahead. I'm this far into it. I might as well finish it up for you. This is negative 6.33. I need negative of that. Nope. Slow down here. There it is, 6.33. I need the negative of that. And I subtract 6.55. That's going to be negative 12.88. Negative 12.88. And then the upper end point, let's do this one more time. The 6.33 again, negative, but I add 6.55. That's going to be 0.22. Okay, now this interval is going to actually straddle 0 here. Okay, so what I mean by that, let's go ahead and just put in some numbers here. The lower end point is negative 12.88. Oops. I'm going to have 0 maybe about in here. Okay, and then the upper end point is up here at 0.22. So again, sorry about this. I should have had a little bit better number line, but this is 0 here. Now, most of this interval does indeed sit below 0 here. But I do have a little bit of the interval, that's out of proportion there. I do have a little bit of the interval that goes up above 0. It actually goes up to 0.22. Now, what did we do here? How did we compute our differences? So let's go back and look at how these differences were computed. They were computed as breastfed minus bottle-fed. So a negative means that breastfed is going to be lower. Okay, a negative means breastfed is going to be lower. So it looks like for most of the interval, breastfed is doing better. But for a little bit, it's not. So because this interval actually goes through 0, I cannot say that a difference exists. And that agrees with what we set up above here. We set up above, if I look at we set up above here, where's my p-value stuff? I said that no, we don't have enough evidence to say a difference exists. That p-value is a little bit above 0.05, which means I don't have enough evidence to say a difference exists. And I'm getting that same information here with my interval. My interval just catches 0 just a little bit here. Goes a little bit above 0. So I can't say a difference exists here. So interpret the meaning of this confidence interval. Well, what we would say here, if I did it exactly with the numbers, I would say we are 95% certain that on average, breastfed babies, breastfed babies will have fluid in their inner ear anywhere from negative 12.88 days to positive 0.22 days more, or let's say we'll have, okay, let's be careful here. We're 95% certain on average babies will have fluid in their inner ear anywhere from negative to positive days compared to bottle-fed babies. Now, what do we mean by negative to positive or negative days here? So a slightly better version might be we are 95% certain that on average, breastfed babies will have fluid in their inner ear anywhere from 12 days, well, let's go from about negative 0.22 days up to 12.88 days less than bottle-fed babies. All right, so that most of the time the breastfed babies are going to do better, right? Because I want this to be small. Now the negative, if this was positive 0.22 days, then, well, if it was just say, or let's say it was positive 1, right, to positive 12, let's make it even easier. Sorry about that, getting on the bottom of the screen here. If this interval was all positive, okay, so from like 1 to 12, then I could say breastfed babies have fluid in their inner ear anywhere from 1 to 12 days less than bottle-fed babies. The interpretation gets a little bit harder here because I don't have a statistical difference. If I did, it'd be a little bit easier to talk about. But instead, what I actually have here is negative 0.22 days. This interval actually catches 0. Now, what I did to you there when I did that interpretation is I actually just put the numbers all positive. So I put this one down below the 0. I put this one up to positive 12. And then I could talk about breastfed babies having less, right? So I just flipped things around so that I could make the English a little bit more straightforward here. That's okay to do that. You just got to reverse both of them. So I put the positive 0.22 to negative, the negative 0.22 to positive. And then I can use the word less here. All right, so I guess the moral of the story here is when I have to interpret a 95% confidence interval when it encompasses 0, that's a little bit harder. The other thing that I would say here is I know with 95% confidence that I don't have a difference. That's what I was talking about a moment ago because this interval actually encompasses 0 or grabs 0. And certainly 0, if the difference is 0, then you don't have a difference between the two breastfed and bottle-fed. Okay, that does it then for the second. That does it then. Oops, sorry about that. Let's see if I can get the. That does it then for section 6.1, pages 9 through 13. Thank you. Have a good night.